Ever wondered how your digital devices interpret binary code? It's all thanks to a fascinating concept in digital logic and design called decoders. These clever circuits convert binary codes into something much more understandable. They play a crucial role in a range of digital systems, from memory systems to display devices. There's a whole world of different types of decoders out there, each with their unique characteristics and uses. Intrigued? Stay tuned to uncover the mystery of decoders. Decoders in the world of digital logic are the magic translators. They are akin to a skilled linguist who understands the complex language of binary code and translates it into a form that our digital systems can comprehend. These are combinational circuits that receive a binary code as input and provide an equivalent output representation. Let's paint a picture. Imagine a room with multiple doors. The binary input is the key that unlocks only one of these doors at a time. That's your decoder at work, activating one specific output line based on the input code. Decoders are like the unsung heroes of our digital systems. They have a wide range of applications, from memory systems and address decoding to display devices. They are the ones ensuring that the right information reaches the right destination. Decoders come in different types, each with its unique capabilities. There are binary decoders, which are quite straightforward. A binary decoder receives a binary input and activates one of its multiple output lines based on that input. The number of output lines is determined by the formula 2 to the power of n, where n is the number of input bits. Each output line represents a unique combination of the input bits. Then there are binary coded decimal decoders, or BCD decoders, which are slightly more complex. A BCD decoder converts a 4-bit binary code into its equivalent decimal representation. This type of decoder is commonly used in applications where the input represents decimal digits. And that's just the tip of the iceberg. There are many more types of decoders, each with its unique role in the digital world. Understanding how they work and what they do is key to grasping the fundamentals of digital logic and design. Decoders, in essence, make sense of the digital language. Let's dive into the world of binary decoders. These fascinating devices are the translators of our digital world, taking binary code, the language of computers, and turning it into an output we can understand. Imagine you're at a party where everyone is speaking a foreign language. You're feeling lost until a friendly person comes over, listens to the conversation, and translates it for you. That's what a binary decoder does, but for digital circuits. So how does it work? Let's take a look at a simple example. A 2 to 4 binary decoder. This decoder has 2 input lines and 4 output lines. The 2 in its name refers to the number of input lines it has, represented by the binary digits A1 and A0. The 4 refers to the number of output lines, Y0 through Y3. Here's how it works. If both A1 and A0 are 0, the decoder activates the first output line, Y0. If A1 is 0 and A0 is 1, it activates the second output line, Y1. Similarly, if A1 is 1 and A0 is 0, it activates the third output line, Y2. And finally, if both A1 and A0 are 1, it activates the fourth output line, Y3. So, in essence, each output line represents a unique combination of the input bits. The binary decoder literally decodes the binary input and activates the corresponding output line. But why are there 4 output lines? Well, if you think about it, with 2 binary digits, there are 4 possible combinations: 0, 0, 0, 1, 1, 0, and 1, 1. So our 2 to 4 decoder can handle any binary input of 2 digits and give us the corresponding output. This is just the tip of the iceberg when it comes to binary decoders. They come in all shapes and sizes, ready to decode binary inputs of various lengths. But regardless of their complexity, the principle remains the same. They take a binary input and translate it into a single, meaningful output. As you can see, binary decoders are quite the binary whisperers. They listen to the language of computers and translate it for the rest of the digital world to understand. Now let's shift our focus to BCD decoders. BCD stands for binary coded decimal. This type of decoder is a digital computing and electronics hardware device that converts a 4-bit binary code into its equivalent decimal representation. Let's consider an example, a 4 to 10 BCD decoder. This specific decoder has 4 input lines, which we'll label as D3, D2, D1, and D0. These lines represent a 4-bit BCD code. The decoder also has 10 output lines labeled from Y0 to Y9, each representing one of the decimal digits from 0 to 9. But how does it work? Well, each combination of inputs corresponds to a unique output. For example, when the BCD input is 0000, the output line Y0 is activated, representing the decimal number 0. Similarly, if the BCD input is 0001, the output line Y1 is activated, symbolizing the decimal number 1. This continues all the way up to the decimal number 9, which is represented by the BCD input 1001, activating the output line Y9. In this way, the BCD decoder effectively translates a 4-bit binary input into the equivalent decimal output. This might seem like a complex process, but BCD decoders are designed to handle this conversion swiftly and efficiently. They play a critical role in applications where the input represents decimal digits, making them invaluable in many digital systems. But why use BCD decoders at all, you might ask? BCD decoders are particularly useful in digital displays and calculators, where the binary numbers need to be presented in a form that's easily understood by humans, the decimal form. They're also essential in certain types of digital data processing, where binary numbers need to be converted into decimal numbers for easier manipulation and understanding. So, BCD decoders in a nutshell are the bridge between binary and decimal. They take the complexity of binary code and translate it into the simplicity of decimal numbers, making the digital world a bit more comprehensible for us. Wondering where these decoders are used in real life? Let's dive into the practical applications of decoders. We've talked about their theoretical aspects, and now it's time to see them in action. Firstly, decoders are fundamental in memory systems. Each memory cell in a system has a unique address. When we want to access a particular cell, we use its address as the input to a decoder. The decoder then activates the line corresponding to that address, allowing us to read from or write to the memory cell. Without decoders, we'd be lost in a sea of memory cells with no way to find the one we need. Next, let's talk about address decoding. In a computer, there are numerous hardware devices, each requiring its own unique address. We use decoders to translate these addresses into signals that can activate the correct device. An address decoder takes the address lines from the CPU as its input and selects one of the outputs to enable the device at that address. This way, the CPU can communicate with any device in the system simply by using its address. Finally, decoders are key players in display devices. Let's consider a 7-segment display, a common type of display used in digital clocks and calculators. Each segment of the display can be lit up to form numbers and some letters. A decoder takes a binary input representing the desired character and outputs the signals to light up the appropriate segments. So when you look at a digital clock, remember that a decoder is working behind the scenes to show you the time. Decoders serve as the translators of the digital world. They take binary codes and turn them into actions, whether that's selecting a memory cell, enabling a device, or lighting up a display. They're like the conductors of an orchestra, directing each instrument to play at the right time to create a harmonious symphony of operations. Decoders thus have a significant role in the digital world around us. Let's bring it all together now. We've journeyed through the intricate world of decoders, understanding their fundamental essence in digital logic and design. These combinational circuits, with their ability to convert binary codes into equivalent decimal or other representations, are the unsung heroes of digital systems. We delved into the two main types of decoders, binary decoders and binary coded decimal or BCD decoders. Binary decoders, with their unique ability to activate one specific output line based on the input binary code, are the backbone of many digital systems. We learned about 2 to 4 binary decoders, which have 2 input lines and 4 output lines, each representing a unique combination of the input bits. Then we explored the realm of BCD decoders, designed to convert a 4-bit binary code into its equivalent decimal representation. We discovered how a 4 to 10 BCD decoder operates, with 4 input lines representing a 4-bit BCD code and 10 output lines representing the decimal digits 0 to 9. Decoders are not just theoretical constructs, but practical tools used in various applications, from memory systems to address decoding and display devices. They translate binary codes into meaningful outputs, making digital systems functional and efficient. So the next time you interact with any digital system, remember the crucial role that decoders play. They truly are the unsung heroes, making sense of the binary world for us all. That's all about decoders, the unsung heroes of digital logic and design.